We're now going to transition into Unit 5, which is going to be based off of linear relationships. And more particular, this video is going to be based off of whether something is proportional or non-proportional, like with these examples here. So we're going to look at tables, we're going to look at graphs, we're going to look at equations, as well as situations, and determine whether or not they are proportional or non-proportional, of course assuming first that they are linear. So, first off, what is a linear relationship? Well, linear relationships describe a straight line relationship between two variables, right? Those variables are your x's and your y's, which will be right here. They are expressed with the mathematical equation y equals mx plus b. All right. Now, of course, we're going to talk about this equation a lot more in depth, but as of now, all you have to do is remember that this right here is going to be our variable, otherwise going to be known as our constant of proportionality, and this right here is going to be known as our y-intercept, or our constant. Okay? Now, of course, for these graphs to be considered linear, they must be a straight line. So if you look at graph A, this is definitely a linear relationship, and this is the constant of proportionality. Over here, you can see that this is not linear. It starts over here and then it curves. So we would say that graph B is not linear. So the first thing you have to remember is that in order for something to have a linear relationship, we must have a straight line. Okay? So let's go ahead and talk about whether something is proportional or non-proportional in graphs. Now, in order for something to be proportional when you're looking at a graph, the line must pass through the origin at point 0, 0. That's the most important thing, okay? Of course, it has to be linear, but the line must pass through the origin 0, 0, okay? So as you can see here, our independent variable, our x variables here are amount spent, and our y variables here is the sales tax. So as you can see, this line is straight, it is linear, so it goes right through the origin. So this will definitely be proportional. Okay? Now over here, you could see that our starting amount is going to actually be 1. Okay? So because it does not start at 0, this is non-proportional. Okay? Over here, it starts at 0, so it is going to be proportional. This over here, it looks like it starts at 4, 8, 12, 16, so this is 4. So the starting amount is 4, not 0. So this is going to be non-proportional. And then lastly over here, this is going to be 100, 200, so the starting point here is 100. This is also going to be non-proportional. So for graphs, it's very easy. As long as you see it going through the origin, it's going to be listed as proportional. If it does not go through the origin, if it has another starting amount that's something different than 0, it is going to be considered non-proportional. Okay, now this one you actually have to do some calculations. So we have some tables here. These are all of our x values. Our x values come first, and then our y values, and here we have our x values, y values, and then here x and y. So for this one, there is a constant rate of change, and I'll show you how to calculate that. The quotient of the independent variable x and dependent variable y are the same. Okay, so here is what that means. If we look over here, I'm going to take y, all my y's, and I'm going to divide it by all of my x's. So for the first one, we got 30 over 2, which is going to be equal to 15. For the second one, we have 90 over 8, which is going to be equal to 11.25. So right there, you could see that the ratios are not constant. So this is going to be non-proportional. All right, if we take a look over here, same thing. We're going to do y over x and find the quotient. So we have 1/5 here. This is going to be equal to 0.2. And then we got 8 over 40, which simplifies to divide by 8, 1/5. So I get the same thing, 0.2. And then we have lastly 13 over 65. So 13 divided by 65 will in fact also give me 0.2. So this is proportional. All right, so that isn't. Same thing over here. We're going to figure out the y over x, so 15 over 25. So 15 divided by 25 is going to give us 0.6. And then we got 30 over 45. So 30 divided by 45 is also going to give us 0.66, but it's going to be repeated, okay? So as you can see here, because we have that repeated number, this is going to be non-proportional, okay? Now, I'm going to do this one another way. I'm going to figure out our change right here. So we have, well, actually, no. Let me just do 7 over 9. I'll save that for a little later. So this is going to be 0.77 repeated. And then we got 28 over 36, which if we divide by 4, that simplifies to 7 over 9. So that one's the same. And then if we take 49 over 63, divide by 9, we get 7 over 63 divided by 9 is going to give me 7. Alright, we actually can't simplify this. Divide by 7, 7 over 9. So 49 divided by 63. Looks like I made a mistake here. So this is going to be equal to 0.77 repeated. Okay, so this one is also non-proportional. Alright, so all you basically have to do is make sure that your ratios are the same. If your ratios are the same, it will be proportional. And I'm sorry, this one is proportional. There we go, because it's going to be 7, 7 repeated. So yes, this one is proportional. Alright, let's move on to another example. Let's take a look at equations. So this one is pretty simple. So if you have a constant, meaning something extra is added, then that means it's non-proportional. So you see right here you have the plus 200. This is going to be non-proportional. Over here we have our variable, but we do have another starting point over here. So this will also be non-proportional. For this one, I'm not adding or subtracting anything extra. This is just a direct relationship. I just multiply by 65 every single time. I'm not adding or subtracting anything else afterwards. So this is going to be proportional. Okay? Now this one, you might want to say that it's proportional, but I need two variables. So you see over here how you have S and then you have P, and then here you have T, then D, and then you have N, then P. These are basically your X and your Y values. Here, I only basically have an X value. I have no Y value. So this is also going to be non-proportional. Okay? Now, let's take a look at the last thing, which is situations. Now, if you think back to Unit 3, when we took a look at situations and then started to create equations, we could do that here as well in order to figure out if this is proportional or non-proportional. Remember, here's the form, y equals mx plus b. If this b is something other than 0, so not 0, then that means it's proportional. And I'm only left with a direct relationship, which is this. So let's take a look. Arena B has a 50% initial fee. So I have a starting amount, but the hourly rate is 200. So if I were to write an equation, it would be y equals 200x plus 50 because of this initial starting amount. Because I have this plus 50, this is going to be non-proportional. Arena A charges an hourly rate of $225. Okay, so it's just y equals $225 per hour. 225x. So in this case, since I'm not adding or subtracting anything extra, this will be proportional. Painter B has an initial fee of $20, but the hourly rate is $35. So this equation, it has an initial fee right here. So it's going to be 35x plus 20. Because of this plus 20, it's going to be non-proportional. And then lastly, a painter charges an hourly rate of $45 with no additional fee. So y equals 45x. So this is going to be proportional. Okay? And that's it, guys.